Yeah, so hello everyone. My name is Itiel Shwartz. I'm the CTO and co-founder of Komodor, and I'm here to talk about Komodor journey to AI SRE, or more importantly, how we took the company that wasn't IA based and transformed it in something like 2 years into something where agentic and AI is a huge part of the overall system. So a bit about myself, in my background, I'm an engineer. I worked in multiple big companies. I work in a couple of startups, and 5 years ago, I co-founded Komodor in order to simplify Kubernetes for our users. And basically, our users is everyone who manages Kubernetes at scale. More than that, I've worked quite a lot with Kubernetes, Python, and over the last 2 years, most of my work is around LLM, how to utilize LLM, not from the co-pilot standpoint, but more around how can I take an existing product and use LLM in order to enhance it. So the agenda for today is a bit on our journey. Then we'll talk about lesson learned, the hard way, around how to actually use LLM in production. And my goal here in this talk is not to talk too much fluff, but more around the actual things that help Komodor to use LLM. So before I get started around the LLM, a bit on our mission. Our mission was to simplify Kubernetes for our users. That is basically true for two main pillars. One is troubleshooting, solve issues faster in Kubernetes. And the second was around optimization, make sure the clusters are optimized. When Komodor started, I was a very a big opposer to AI. So we started the company 5 years ago. In that time, AI Ops was a term that a lot of different companies used. As a past SRE myself, I felt that it's mainly a marketing stunt. Most AI were glorified regex. And in the first couple of years of Komodor, we didn't have any AI. We didn't have it in our site. We didn't have it on our backend. And in general, the vibe or the atmosphere was that AI is not really prime for things like AI for SRE. That being said, as you all know, LLM became very popular, right? With the use of ChatGPT and Cloud and so on. And with that, we started to explore, can we use AI in order to do what we want to do, which is basically simplifying the life of our users and developers and DevOps. So we wanted to use LLM. We saw that internally we are using quite a lot of LLM already, right? To write code. Sometimes we took Kubernetes errors and we put them inside of ChatGPT. And we said, okay, why can't I just replicate everything that the human is doing? Take the error from ChatGPT, from Kubernetes, paste it into ChatGPT, and that will be the first version. I'll say that the first iteration of using LLM to solve real complex problems in Kubernetes were horrible. A lot of hallucinations, a lot of problems, a lot of issues, nothing work. And on one side, there's a very big promise of automating everything and shift left and things like that. But in reality, when you write the first line of code, when you try to validate yourself, you see that nothing actually works. So there was a lot of frustration back then. We really wanted to implement and to use LLM on one hand, but nothing worked for us on the other hand. And we tried to understand what should we do so that journey can be successful. How should we change the way that we work? So I'll take a long story short. I'll say that the main problem of all LLM in general for high throughput or big data system is a question of context. If you give the LLM too much context, then everything that you're going to get is probably hallucinations, he will go mad, and nothing is going to work. On the other side, if you don't give the LLM enough context, then he's simply going to give very bad answers, and it's very hard to find that balance. In Komodor, the way that we are currently solving it is by taking very large problems and then trying to separate them into smaller and smaller agents. Smaller and smaller, let's call it models that are very specific. And then you need some huge or some very smart orchestrator LLM in order to solve all of that. But other than the fact that we took everything and we separated it, I think that the thing that allow us to advance in the speed and the velocity that we were able to move is because we spent most of our time in the validation. So I think that it's one of the things that people are not really talking about. Usually when you read like LLM guides, there are some that are scientific papers around like very smart validations that are done by Google or Anthropic. On the other side, there's the Hello World guide. This is how you implement an LLM using Python. But somewhere in between, there's the question of, okay, I just wrote my first LLM agent. This agent, everything that he does in life is, I don't know, like to read the log line and to tell us if there's a really big problem or a really big issue. But then how do I validate it? How can I make sure that it actually works? And for us, we had, because in our space, you don't want to give the bad recommendation, the first thing was do no harm, right? Like you should always do what a really senior SRE would do, but always take into account that you can't really do harmful things. What is harmful in Kubernetes? Delete the namespace, for example, delete the cluster, change the replicas to 0. It might solve the problem, but it's not what a really good SRE would do. So we always try to ask ourselves what a really good SRE would do. Secondly, was around the depth. And when we started this project of LLM, there was a question. Kubernetes is very complex. A lot of users are suffering, even it's very fun. What should we do first? And we decided to tackle what we thought is the most critical problem, a pod that is not working correctly in Kubernetes, as the first problem that we are trying to solve. And that problem, which sounds, I don't know, like very small, or might sound very small, took us, I think, a couple of months in order to gain like enough confidence to show it to customers. And when you open a startup, a lot of the times people tell you like do things that doesn't scale. When you work and you are building LLM in production, you need to have the same mindset. It's much more important to have one use case that you are confident at than having a lot of use cases that are not really that good. And thirdly is around the coverage, basically adding more use cases as we go. So in Komodor, what we always do when we have a new use case is, first of all, let's make sure that it can destroy our customer environment. Okay, that's great. Second, we start with something quite small, and then we expand and expand and expand. And in that way, you have the confidence, you have the understanding of what the LLM does well and what it doesn't really excel at. And on top of that, you are able to build things forward. Now, when we're talking about, okay, like everything sounds good, but what should I actually do? Like I'm starting my development journey right now. What's your best tips or tricks? So first of all, I think that a lot of the things around LLM-based development sounds like scientific, and a lot of the times I feel there's a lot of very like sexy name, if you will call it like that. But in reality, there are principles that we work for like years and years in the software development lifecycle. So first of all, like local development is key. I think that people who wait for their LLM to reach production are probably moving way, way, way too slow. LLM in its nature is very unpredictable, and local development, or the ability to run a lot of data set in your local environment, is crucial. In Komodor, by the way, we found out that every new addition requires something like 50 different iterations before we deploy it into production. So if I write a Python code, for example, usually I have some confidence that it's going to work. On the other side, when I change an LLM prompt and tool set and so on, usually I have no idea if that's like the best thing I can do or the worst thing, and everything is going to fail now because something went wrong here. Secondly, is more around the testing itself. I'm using like the term shadow agent, golden standard. It's a lot of things that I see more and more in the industry. In reality, it's basically A/B testing, which is like having two different agents competing, trying to solve the same problem, and test cases. So again, like we spent the first couple of weeks building this agent, the first version of the agent, in just preparing a lot of test suite. These test suite were tests that we knew, we understood, we knew what should be the root cause, and that allowed us to have a lot more confidence because we knew what the LLM should give us as an answer. Lastly is LLM as a judge, which is a bit more tricky. It is trying to take your experience, the domain knowledge experience basically, and to bake it into an LLM. The problem with LLM is you can't really trust it. And then there's the question of how can I trust my judges, right? Like who judges the judges? And it's one of the things that we still struggle in Komodor. Like how can we make sure that our judges are correct? And over the last couple of weeks, we have a new sexy use case. And we basically wrote an LLM as a judge for our LLM as a judge, which is a bit recursive, I know, but we simply couldn't trust our existing judge. Like we felt that they are a bit off. So when we're talking about local development, what do we mean? Again, like it sounds a bit basic, but the ability to run the LLM from your local desktop, or again, for something that gives you very fast feedback cycle. And in Komodor, we were able, in the first version, each new iteration took us 60 seconds, something like that. After we worked quite hard on that, we were able to slice this to something like 20 seconds. And other than the fact that I felt better when I ran this code, it allows us to do much more iterations. It allows us to do much more smaller changes. And again, in this LLM-based development, speed is key. And if you are unable to move fast, then you are simply going to wait to production, understand that your LLM is not doing what it is expected to do, and then wait quite a lot of time before it can actually work. So local development is critical, and the ability to move fast is not a nice to have like in other development projects. It's a must-have, and we're still doing everything in our power to make sure that we're able to move very fast locally. That means that sometimes you can stream some of the production data anonymized, or the ability to have a lot of different synthetic data in place so you can play with it. But it's crucial to have that kind of capabilities in order to move fast. Secondly is our ability to have this golden standard. Again, it's like a very fancy name to test suite. So we created a very elaborated test suite. This test suite is not something that is static. It's not like 1 + 1 = 2, because our agent is quite complicated. So we needed to create new clusters or new use cases that really mimic the real world, and then let our agent try to solve those problems. Again, without that, what happens when you develop a new LLM, you see its answer, but you have no idea if it was correct or not correct. And one of the biggest problems with LLM in general is that they always like to please. They really want to help you. They really want to give you the best answer they can, even if they are not that sure. So when you're unsure what is the right answer, it's very hard to judge them. Once you know that you have this test case, it's much easier to understand if you are going into the right direction, yes or no. Secondly is the shadow agent. Again, I told you it's like a very fancy name for A/B testing. It is the ability to run multiple agents trying to solve the same problem. Again, in very noisy environment, in big data environment, it's very hard to mimic reality, right? Like it's very hard to create the exact use cases, the exact test cases as in production. So what we're doing in Komodor, before every new release, every new big release, we have another agent, like the candidate agent. He's running in the background. And then we're able to understand if the new version is better or worse than the previous version. Again, reaching this level of confidence took us a lot of time, a lot of development. It wasn't easy, but once we had it in place, we saw how, in a couple of days, our velocity tripled, because we were able to push a lot of things through production without fearing that we're going to break production or to hurt our customers. And again, in reality, it allows us to move in the velocity that we wanted to move. And what you see here, I'm not sure if you can, it's very bright. But in general, it's our LLM as a judge that help us to validate different A/B testing. And lastly is the LLM as a judge. Like I told you, you can't really trust LLM, never. So you can't really trust your judge, but I do think it's the best thing you can do. So one option might be to hire a bunch of analysts or people that will just grade and do the labeling for you. In Komodor case, it's almost impossible. First of all, we have a lot of customers, a lot of data, and so on. Secondly, our problem is very Kubernetes DevOps specific. And that means that in order to solve those kind of problems, we needed expert DevOps to grade each and every session. So instead, what we had is the ability to bake our knowledge, our expertise into LLM, and to let the LLM grade it. Again, it provided quite good result and allow us to move very fast. And like I told you, like in the last couple of weeks, we did hit a wall. We did feel that our agent is not accurate enough. And we did the same thing that I talked about in the previous slide, the shadow agent. So we created 2 different LLM as a judge. Both of them are trying to grade the same session. And then we are like using another LLM as a LLM as a judge or whatever to make sure that it actually works and that our judges are okay. It is obviously a combination of manual validation on one side and automatic validation on the other side. Like it never works one without the other. So before wrapping it up, I'll say that I feel that like data scientists, like legacy data scientists, are no longer the cool kids in the research group, right? Like there's a lot of LLM hype. In Komodor, when we try to do more complicated use cases, when we try to understand, hey, can we help our customers to solve really big problems, we saw that the LLM hit a barrier, or even more than that, it simply crashed into like a wall. We got a lot of hallucinations. We showed our users like data, again, like it was like in a beta testing and so on, but we showed our users data that wasn't really accurate for cascading failures. And the reason for that cascading failure is basically multiple failures in the same time. LLM simply can't work efficiently. So what we did in Komodor is we combined traditional ML together with LLM in order to provide the best results for our users. So we have layers and layers of traditional ML that allows to do some clustering and to do a lot of the cleaning. And then LLM comes in order to give the real depth to the scenarios. So just to conclude, if you're trying to build your first LLM in production for a real company with a lot of data, the first thing that I think is crucial is like trust, to put trust and precision above anything else. I think it's crucial so you will have the confidence to move forward. Then the thing that I really want to emphasize is that the speed, your velocity, is what's going to determine if you are going to be successful, yes or no. So if you can't move fast, then you are going to get very frustrated. You'll wait for production and nothing is going to work as you expect it to work. Instead, try to make sure that you are moving very, very fast locally. And then once you do hit production, have the ability to run different experiments to make sure that your code actually works, that the LLM actually works. And again, like those things can be very frustrating, even for us, where we worked on those kind of things for quite a lot of times. Every time when we add a new use case, for example, we added like auto remediation or something like that, we still feel it very slow slope of like going up, like nothing works, LLM is hallucinating, why doesn't it work? Why can't I make it work? And then slowly but slowly we're able to move faster until we reach to a good state, but it makes sense. LLM-based development is much more chaotic compared to your traditional development. So that's pretty much it. I'm not sure if I have like an ending slides. It's been a pleasure and thank you.